Chapter 10 Theories of Acids and Bases. The Smart Book topics covered are in Chapter 16, namely, all sections except for Section 16.9 to Section 16.12. Only some parts of Sections 16.9 to 16.10 are relevant. Subtopics for acids and bases. Introduction to acids and bases. Molecular structure and acid strength. Hydrohalic acids, oxo acids, carboxylic acids. Acid-base properties of water, the pH and pOH scales, strong acids and bases, weak acids, and the acid ionization constant Ka, calculating pH from Ka, percent ionization, using pH to determine Ka, weak bases and base ionization constant Kb, calculating pH from Kb, using pH to determine Kb, conjugate acid-base pairs, the strength of a conjugate acid or base, titration curves, and choice of an indicator, buffer solutions. For subtopics 10.8 to 10.10, only qualitative explanation is required. A detailed quantitative treatment, that is, calculations, will be covered in Further Chemistry 1. Learning outcomes. Apply Arrhenius and Bronsted-Lowry theories of acids and bases. Explain the concept of conjugate acids and conjugate bases. Explain qualitatively the differences in behavior between strong and weak acids and between strong and weak bases in terms of the extent of dissociation. Define the terms pH, pOH, Ka, Kb, and Kw. Calculate the concentration of H+ ions and pH values of strong and weak acids and bases. Explain the choice of suitable indicators for a given acid-base titration, and briefly explain what buffer solutions are used for. The butterfly pea flower, grown in Southeast Asia, is used to prepare some Malay, Peranakan, and Thai food and drink. For example, teas may be prepared from the flower. Without acidic lemon juice, the tea looks turquoise, but with lemon juice, it appears purple. The phenolic compound in the flower that changes color is pH sensitive. The pH of a solution reveals its acidity or basicity. It isn't only the butterfly pea flower that is pH sensitive. We and aquatic creatures are too. For example, various biochemical processes in the human body maintain the pH of blood, while fish and plants living in rivers thrive in waters that have an optimal pH range. Outside of the optimal range, we and aquatic life forms begin to fall ill and may die. But what are acids and bases? Acids and bases are either strong or weak. What are strong acids and strong bases? They are strong electrolytes which dissociate or break apart totally in water to form ions. Here are examples of strong acids and bases. All the hydrogen halides except hydrogen fluoride form strong acids when dissolved in water. Thus, hydrochloric acid HCl, hydrobromic acid HBr, and hydroiodic acid HI are strong acids. Other strong acids are nitric acid HNO3, chloric acid HClO3, perchloric acid HClO4, and sulfuric acid H2SO4. The hydroxides of the alkali metal family are strong bases, namely lithium hydroxide LiOH, sodium hydroxide NaOH, potassium hydroxide KOH, rubidium hydroxide RbOH, and cesium hydroxide CSOH. Other strong bases are calcium hydroxide CaOH2, strontium hydroxide SrOH2, and barium hydroxide BaOH2. These three are the hydroxides of the heavier alkaline earth metal family. That is, they are from periods 4, 5, and 6 of the periodic table. An example is the dissociation of NaOH in water to form sodium cations and hydroxide anions in aqueous solution. The arrow used here is a single arrow, which means that this reaction is essentially irreversible. What are weak acids? A weak acid is a weak electrolyte. That is, it does not dissociate completely in water. In other words, it only partially dissociates in water. The example shown here is that of hydrofluoric acid. It is split apart by water to form H plus cation and fluoride anion in aqueous solution. Although water is not explicitly written, the state symbol Aq, which represents aqueous, implies that water is present. The H plus ion is also called a proton. A double arrow is used here as the reaction between HF and water is a reversible reaction. The forward reaction is that between HF and water to form ions, while the backward or reverse reaction is that between hydrogen ion and fluoride ion to reform HF and water.